Today we'll be discussing about the IoT platforms design methodology. Actually, the platform design methodology is required to design the IoT systems, which can be complex and challenging. And it often involves interaction between various components, like there are devices, network resources, web services. Then we have on the cloud analytics components, applications are also there, database servers are there. Okay, so normally a design flow should be followed to like design this IoT devices. So in this case, we will be discussing a generic design methodology for a IoT system design, which is independent of specific product. That means you can design a device for any sector or using any programming language, using any hardware. Okay, but you can follow this generic design methodology. So if we consider the design methodology, we have these steps. The first step is the purpose and the requirements. Okay, or we call it the design specifications. So where we define the purpose of the IoT device and the requirements of the IoT device, like what it is supposed to do. Then the process model specification. Here we define the different use cases, like how the device is going to be used. Next is the domain model specification, where we divide the objects into physical entities, virtual entities, then devices, resources, services, and then we try to establish the communication or the relationship between them. Then again we have the information model specification, okay, where we define the structure, basically the relations and attributes of all the information in the IoT system. Similarly, we have service specification, where we map the process and the information models, and we define the service specifications. Okay, how the process model and the information model map into each other, that is what we will be discussing in the service specification. Next is the IoT level specifications. Actually, there are 6 levels of IoT devices. So we are discussing those in this particular category, and we will also discuss how a particular device fits into one of these level specifications. Then there is the functional view specification, where we have different functional groups and we map the IoT level to the different functional groups. So next is the operational view specification, where we define the communication options, the service hosting options, similarly the storage options and the device options. So how we will be implementing the device, what is the choice of devices, what is the choice of software, all these things we discuss in this operational view specification. Next is the device and component integration, where we deal with development of the device. Actually, the actual hardware device is developed during this phase, and the last phase is the application development. Once the hardware is complete and the cloud is ready, we can actually deploy our application, and based on the application, the user can control the device or can read the information from the IoT device. So beginning with the design flow, the first step is the purpose and the requirement specification. So here the first step in the IoT system design methodology is to define the purpose and the requirements of the system. So in this step, the system purpose, behavior and requirements are captured. It's like a design specifications or the requirement specifications document. So it has to be developed first, then only the whole IoT system will come up. For example, here we have a home automation system. So we can define its purpose, that it will be a home automation system that will allow us to control the lights in a home remotely, and that will be using a web application. And how is the behavior? So the device will work in 2 modes. One is the auto mode, the other is the manual modes. In the auto mode, the system will measure the light level in the room, and it will switch on the light when it gets dark. Whereas in the manual mode, the system provides the option of manually and remotely switching on or off the light. Similarly, we will also have some system management requirement. So the system should provide some remote monitoring and control functions. Okay. Similarly, from the data analysis point of view, it is expected that the system should perform local analysis of the data. That means there will be no cloud deployment here. All the data etc. are to be held on the device itself. Then the application deployment requirement. Here the application should be deployed locally on the device, like I told, and there won't be any cloud component here. All the application will be also deployed on the device itself, but that application should be accessible remotely. Okay, so similarly there is a security requirement. The system should have basic user identification using some login ID and password. Okay, so these are the requirement specifications of the device, or we call it the purpose and the requirement specification. Here the device purpose is actually known. Next is the process specification. So in this step, the use cases of the IoT system are formally described and based on and derived from the purpose and requirement specification. Once we have the requirement specification, we can now go for the process specification. So if you recall, for the home automation system, the process specification for this looks like the one shown in the diagram. So here the user selects the mode. The mode can be auto or manual. So if the auto mode is selected, as you see the decision box here, if the auto mode is selected, then the system will sense the light level. Okay, and once the light level is low, it will turn the light on. Okay, so decision is being made whether the light level is low or high. So a decision will be made whether the level of light is low or high. If the level of light is low, the light will be turned on, while if the level of light is high, it will be turned off. Similarly, if the user chooses manual mode, then the light state has to be red. So how the user has set the light state, it is to be red. If the user has set light state to on, the light will be turned on, while the user has set the light state to off, it will be turned off. Next is the domain model specification. This is the third step in the IoT design methodology and is used to define the domain model. It actually describes the main concepts, entities and objects in the domain of IoT system to be designed, and it defines the attributes of the objects and relationships between the objects. So there are a few entities and objects in this model. First is the physical entity. So physical entity is a discrete and identifiable entity in the physical environment, such as a room, a light, or a appliance, a car are all physical entities. Similarly, virtual entities. Virtual entity is a representation of the physical entity in the digital world. It's a kind of digital twin, you can say. So device provides a medium for interactions between physical entities and the virtual entities. So devices are either attached to physical entities or placed near the physical entities. Similarly, we also have other objects called resource. Resources are basically software components which can be either on device or network resources. So if it is a device resource, it is hosted on the device, whereas network resources reside in the network itself. Similarly, another entity is the service. Service provides an interface for interacting with the physical entity. So they access the resources hosted on the device or the network resources and are used to obtain the information about the physical entity or perform certain actuation upon the physical entity. Here we can see the domain model specification of a smart home system. So the physical entity, as you see in this case, is the room as well as the appliance. Appliance here is the light bulb. So there are actually the virtual representation of these physical entities, which is the virtual entity, as we can see. And then to make the communication between the physical entity and the virtual entity, we have the device. So here is the device, and then we have the sensors and actuators which are connected to this device. So here certain arrows are used. If there is a skeleton arrow like this, it's a one-way association. Okay, and similarly, if there is a solid arrow, it's generalized or specialized relationship. Similarly, if there is a solid diamond arrow, it represents aggregation relationship or close relationship. You can say multiple parameters might be related in this case. So here, as we see, these sensors and actuators, these are related to this device, and then device, on top of this device we have some resources running on it. So resources here are, as we discussed, the on device resource, the network resource. Together they make the resources, and on top of that we have this service which is running to basically run some REST based or RESTful services that will be exchanging the data. And then we have the application running here. The application is operated by the user, and in this case it is a human user who will be interacting with the application. So as we can see, the relationship between the different entities are shown in this diagram. Similarly, next is the information model specification. The fourth step in the IoT design methodology is to define the information model, and it defines the structure of all information in the IoT system. For example, attributes of virtual entities, relationship between them, all these things. So let us look into the information model specification here. So here you can see there are these two entities which are the virtual entities. Okay, so we have one virtual entity is the light appliance, the other is the room. So here, as we see in this uh, virtual entity which is the light, okay, the entity type is, it is a appliance, the ID is light 1. Similarly, room ID is connected in room number 1. So the attribute or the state, here the attribute is the state, because light can have two states, which is on and off. So these are the two states, as we can see. So this light appliance or this virtual entity actually resides inside this virtual entity, which is the room, and the entity type is, as we can see, is room, and ID is room 1. So here the attribute is the light level. Light level can be high or low. So to represent that, we have this models. Next is the service specification. This is the fifth step in the IoT design methodology, and it is to define the service specifications. Service specifications define the services in the IoT system, the service types, the service input outputs, then the service endpoints. Service schedules are also there, service preconditions, like what condition when met will turn on the light or turn off the light, and then the effect of the service, which device will be actuated. So here in this diagram we can see the process specification and the information model both in a single slide. So here we can also see the mapping between the different processes. So the light level sensing attribute here is mapped with this process here, light level process here, and similarly the attribute state of the light bulb is as mapped with the light state. So here there are three kinds of service that will be running in this case. So one is obviously the mode service, which sets the mode to auto or manual. Okay, so when it is auto mode, the system determines the light level and turns on the light automatically, whereas in manual mode the user sets the light to on and off. Then again there is something called the state service, where which sets the light appliance state to on or off, or retrieves the current light state. Similarly, we have a controller service. So we have a controller service here which does two jobs. In the auto mode, the controller service monitors the light level and switches the light on and off, and it also updates the status in the status database. Similarly, in manual mode, the controller service retrieves the current state from the database and switches the light on or off. Similarly, we also have the IoT level specifications, or these are the basically the templates on which the IoT system can be developed. So in this case, it is following the IoT level 1, as we can see, because there is no cloud-based services defined here. So we have the device on top of which the device resources are running, which will be sensing the data or actuating certain uh, actuators or relays. And then on top of that, we have a controller service, which is basically a RESTful service. The controller service controls the device based on the mode set by the user through the application. There are REST services that are running and there is a database connected with it. The REST services are responsible for hosting the application also, on which the user will be able to send commands. The next is the functional view specification, which defines the functions of the IoT systems grouped into various functional groups. So each functional group has its own responsibilities or functionalities for interacting with instances of concepts which are defined in the domain model. So basically, here we are mapping the previously designed domain model specification with the functional groups. So here, as we can see, the first functional group is the device function group, which is responsible for monitoring and control. In the case of our home automation system, the device function group includes the single board mini computer, the light sensor, relay switch, etc. Similarly, we can also have communication function group, which handles the communication basically. So here in this case, it could be REST based or WebSocket based. In the case of the home automation system, however, we will go for REST based APIs because the data communication is not that real time, or there is no continuous flow of information. Similarly, we have the service functional group, which is involved in the different kinds of services. It can be for device monitoring, device control services, data publishing services, or it can be services for device discovery. Similarly, there is a management function group, which includes all the functionalities that are needed to configure and manage the IoT system. It can be to manage the resources on the device also. Then we have the security. The security function group includes mechanisms for IoT systems such as authentication, authorization, data security, etc. Similarly, we have the application function group, which includes applications that provide an interface to users to control and monitor the various aspects of the IoT system. So here we can see a mapping between the device levels or the IoT level specifications. So the level 1 IoT device has been mapped with the different functional groups. The device functional group has been mapped with the device and the resources, whereas the communication functional group is mapped with the controller service and the REST based web services. The management functional group is again mapped with the different resources on the device as well as the controller service. We have the security functional group, which is mapped with the application as well as with the database for the authentication and authorization. We have the services functional group, which are responsible for running the different services. So it is mapped with the different services. It can be controller service or the web services. Then we have the application functional group, which is again mapped with the application itself and the related blocks. Next, we have the operational view specification. In this step, various options pertaining to the IoT system deployment and operation are defined, like service hosting options, storage options, and the device options and application hosting options. So that means we define the different software that will be running or the hardware that will be used in the case of constructing the IoT system. So in devices, we can go for Raspberry Pi or some other contemporary development boards. Similarly, light dependent register can be used as a sensor, and a relay switch or a can be used as a actuator. Similarly, discussing the communication APIs, we can go for REST based APIs. Now for communication protocols, the link layer can be based on IEEE 802.11 or the Wi-Fi. Network layer will be based on IPv4 or P6, and the transport layer will be based on TCP, while the application runs on the HTTP. Similarly, in the operational view specifications, the services can also be defined. Like the controller service can be hosted on the device and it can be implemented using the Python, and it can run as a native service. Similarly, for mode service, we can use RESTful web services. Similarly, for state service, also we can use the RESTful web service. In the application category, we can have the web application, that is Django web application. The application server will be again based on Django app, and the database server will be based on MySQL. So for security and management point of view, for security we have for authentication the web app and database, and similarly for authorization we have the web app and the database respectively. And for management, for application management we have the Django app management. For database management, MySQL DB has been used, and similarly for device management the Raspberry Pi device management has been used. So here we can see a mapping between the different functional groups as well as the different services, and we can also see the different like software or different hardware that we finalized during the previous operational view specification. Okay, those are actually implemented or mapped into the different functional groups. Similarly, there are, you can see native services and web services are there, they are mapped with the services. Similarly, the management services are mapped with the management functional group. Accordingly, the different functional groups have been mapped. Similarly, for device component and integration, this is the one of the major steps. Original hardware comes into life. The devices and component, for example, that have been used here for implementing the home automation system is a Raspberry Pi and a LDR sensor as well as a relay module. And we can see that there is a driver IC for this particular relay module here. So once the hardware has been developed, the next step is the application development, and this is the final step. And if we consider the home automation system, okay, the application can have the controls for auto and on and off mode. For example, you can see this. Here is the interface for the web application where we have a auto mode, and then once the manual mode has been selected, the light can be turned on and off, and if there is the auto mode, the status of the light can also be read. So this is the final step and the application is developed. So now let us have a case study of a weather monitoring system. So here we will have the domain model as well as the process model and the other model specifications. Okay, so let us look into it. So first is the domain model specification. So here, as we can see, the physical entity is the environment, and obviously it is also represented as virtual entity. So the device here that we have is again a mini computer like the Raspberry Pi, and attached to it are the different sensors. There is a temperature sensor, pressure sensor, humidity sensor, and light sensor respectively. So these are all related with this device. And then, like in the previous case, there is a network resource, and then there is an on-device resource that are connected with this resource. So these are related to this resource, and on top of the resource there is a controller service that is running here. And then we can have the application. So there is a active digital artifact application is there. The application can be used by a human user here. So in this case, as we can see that a lot of data is being collected, so local processing might not be feasible, and we might require some kind of cloud based processing. So now let us look into the next figure. So there are a few services running here. There is a schedule service that runs, and at every 15 seconds it collects. It actually informs that 15 seconds has elapsed, and then the sensor measure the temperature, pressure, humidity, and light respectively. So then there is a REST service to store these measurements into the cloud. So then there is this IoT level specification, and the IoT levels. This is a IoT level 6 device. So here we can see some local nodes are there, So these are the devices that are collecting the different information like light, humidity, all these information, pressure, etc. These are sensing. So here in this model also we can see that there are multiple monitoring nodes which are connected to a centralized controller, and there is cloud storage and analysis. So as we can see here in this diagram that there are devices, and on top of the device there are the different resources running, and on top of that we have the controller service running where some REST based communication is happening, and basically the controller service is responsible for sending the data to the REST services that are running on the cloud, and it also communicates with the centralized controller which actually controls the different nodes, and then the data can be stored in a database. So this analytics component actually generates the different kinds of visualization, and it finds patterns in the data. Besides this, we have an application through which the user can interact with the services, and then we can have multiple observer nodes where we can visualize this IoT systems data and working. And as we can see, this is a mapping between the different functional groups and the different components of the IoT device. The IoT level 6 has been again shown here, and then to that the different functional groups are mapped. So the IoT device maps to the device functional group, as we can see here, and it is also mapped with the computing devices, sensors and computing devices which are all there on the device functional group, and also with the device management functional group in the management functional group. Similarly, there are resources which are mapped to the device and communications functional group. Similarly, there is a controller service which maps to the services functional group. So different kinds of functional groups have been mapped in this case. And here we can see the operational view specifications where all the different devices and the applications that have been selected to implement this device have been listed, and they have been mapped with the different functional groups. Like for management, again the same Django app management, MySQL database management, and Raspberry Pi device management have been used. But here, as we can see, the number of sensors have increased to include the temperature, humidity, pressure, and light sensors respectively. Similarly, from the application point of view, we are requiring here some Hadoop basically to work on the big data that is being gathered by the IoT devices in the cloud. Similarly, we also have some cloud app and mobile apps here, and then since we are working with the cloud storage, that's why this Lively cloud storage has been used here, and respectively these have been mapped with the application function group. Now next is the device implementation, where here you can see a Raspberry Pi has again been used, and then to sense light we have this LDR sensor that is available, and since the Raspberry Pi doesn't have its own analog to digital converter, that's why another IC has been used here along with it to sense the amount of or the intensity of light. As per my experience, I feel this is a simple analog to digital converter that has been implemented in here. And then we have this pressure sensor that has been connected using the I2C interface. It's a very good communication protocol, I2C, which has been developed by Philips. Apart from the power supply pin, it only requires 2 pins to be connected, which is the serial clock and the serial data, to enable the synchronous data transfer. So this SCL is for serial clock and SDA is for serial data that have to be connected to the Raspberry Pi. Besides this one that you see here is a DHT sensor, digital humidity and temperature sensor, okay, which is connected to a digital pin of the Raspberry Pi. Certain libraries are there using which you can easily communicate with the sensor. So this is where basically we can say that this is a device prototype. So this is all about the IoT platform design methodology.